Okay, ladies and gentlemen, welcome back to lesson 2. Today we will be talking about domain and range using interval notation. So as always, let's begin with a repeat and review, and then we'll dive into today's objective and finish it off with some examples. So let's begin with last time. So last time we used interval notation in order to represent a set of solutions that is bounded by a lower bound and an upper bound. So here it's bounded from below by a positive 2 and bounded from above by a positive 7. Now, when you have open circles, the convention is to close it with a parentheses, and when you have a closed circle, the convention is to close it with a bracket. So here, the interval would be represented by bracket 2, comma 7 parentheses. Alright, so now we're going to extend this to the graph, to a bunch of graphs. So using graphs, we're going to apply the same concept, and that's going to basically relate to the domain of the graph. So here, you can see that we have a closed circle, and we have a open circle as my endpoints. So the domain of this graph would be bracket 2, comma 7 parentheses, and this would be the domain. So that's the direction we are heading to. So let's practice with some examples. Let's begin with this one. Or actually, before we begin the examples, let's review the definition of domain and the definition of range. So the domain is basically all of the values that go into a function. The x values, or in particular the x-axis, you'll see that we're going to be moving horizontally. For the range, this is going to be the output values. In other words, we're going to be looking at the y values, the y-axis, and you're going to see that we're going to be using a vertical movement. So now let's put this into perspective with an exercise. So let's look at this one. This problem is asking for the domain, so I have to look at the x-axis, and in order to get the x values, we have to move horizontally. Now the objective is to begin scanning this graph starting from the left and then moving to the right. So let's begin. So I'm going to start left, and then I'm going to have to move to the right, and I have to encounter my lower bound. And you see that I encounter my lower bound starting here at -4. So since we have a closed circle, I'm going to create a solid line here. Okay, so that's my lower bound at -4. And now I have to find my upper bound. So I have to keep going to the right, to the right, to the right, to the right. And you see that my graph ends right here at +1. But we have an open circle. So I'm going to create a dotted line right here. And here it's at 1. So now basically all of these values from here that I'm highlighting in red, those are my inputs. This is basically representing the domain of this graph. And if I want to express it in interval notation, I'm going to do so by using these as my endpoints. So I have -4, 1, and now this dotted line is telling me that I have to use a set of parentheses to close my upper bound of 1, and this solid line is telling me to close my lower bound with a bracket. So the domain of this graph is -4, 1, and using interval notations, I use a bracket to close the -4, and I use a parentheses to close the +1. Let's try another problem out. So here, again, we're interested in getting the domain of the graph. So we're going to be looking at the x-axis, again, horizontal movements beginning from left and scanning the graph to the right. So I'm going to start at the left, and I'm going to begin scanning to the right. So I keep going, and I want to see where I first encounter my graph. At what value do I encounter my graph? And you see that I encounter the graph here at a +3. Since here this graph is continuous at 3, we're going to assume that this is a closed dot, so we're going to use a solid line. So here the lower bound is positive 3. Now I have to keep scanning the graph, see where it ends in order to get my upper bound. So I keep going, I keep going, I keep going, I keep going, and you see that the graph ends here at this positive 7. Now I have an open circle, so I'm going to have to slice through it with a dotted line here. And now this is going to be my upper bound, 7. So the domain is the set of all of these x values that I'm highlighting in red, and I want to express them using interval notation. In order to do that, I'm going to use the endpoints 3 and 7, and then I'm going to use a set of brackets and parentheses. So the domain of the graph is going to be 3, 7. The 7 I'm going to use a parenthesis, the 3 I'm going to use a bracket. The bracket comes from the fact that this was a closed circle, and the parentheses comes from the fact that this was an open circle. So let's attempt one more. So now here we're trying to find the domain. So I want to reiterate that we have to be looking at the x-axis, moving or scanning the graph from left to right. So I'm going to begin at the left, and as I begin to scan, we see that at -5, that's the value in which we first encounter this graph. We have a closed dot, so I'm going to slice using a solid line. That's going to be my lower bound. And now I have to basically explain where the graph ends. So I keep moving to the right, to the right. So I keep going, and you see that my graph ends here at this value at -2. Again, it ends if we're interpreting a horizontal movement left to right. I have an open circle this time, so now I'm going to slice it using a dotted line, and this dotted line represents the upper bound. Okay, so now this is the set of all of my inputs that are within these two boundaries, and if I want to represent them in interval notation, I'm going to write my endpoints -5, -2. The -2 is going to be closed with a parenthesis, and the -5 is going to be closed with a bracket. Again, to reiterate, the bracket comes from the fact that this was a closed circle, and the -2 with parentheses comes from the fact that here we had an open circle. Alright, try these problems out and get the domain.